Okay, this video is on doing question 9.8. So you have this trough that's a circle, and we want to know its width as a function of time. And the water level is going up 2 inches an hour, which is 1/6 feet per hour. And so again, we want to know the width of that water as it goes up in this circle. So the width starts off at 0 and then goes up to 10 feet. Okay, so we know it's a circle. So we can put, of course, the origin at the middle. So if I put our coordinate in here, I'll use green, which maybe you can see. So there's our coordinate system. And so we want to know what the y value is as a function of time. As the y goes up, we know what the y value is as a function of time. It goes up, and so we want to find what 2 times the x value is, because the x is half the width, so the full width is 2x. Okay, so I can write that down here. Let's say the width is equal to 2x, and we also know it's a circle. So, and again, we're going to use everything in feet, so 2 inches an hour is 1/6 foot per hour. So we know that x squared plus y squared equals 5 squared, or 25. So x squared is equal to 25 minus y squared, or x is the square root of 25 minus y squared, and we want 2x, so we'll have 2 times that. But what is y? And we know that y starts off as -5, right? This is a negative part of the circle. So y starts off at -5 and adds 1/6 an hour. So it's kind of like parametric equations. So y is equal to -5, because again we're starting off negative because this is 0. So -5 feet plus 1/6 t. 1/6 feet per hour times the number of hours. So just like parametric equations here. So it's nice to put the negative backwards. So y squared is equal to, let's just say, t over 6 minus 5 squared. And we can just leave it like that. So the width then, which is 2x, is then 2 times the square root of 25 minus that. So 25 minus t over 6 minus 5 squared. And there's lots of ways we could write that. We could multiply all that out. But it's okay to leave it like this. I think that's the way the book does it for their answer. So to match their answer, we can just leave it like that. So that is the width. Okay, so then they want us to know what the domain is and the range. Well, the domain, what values are there for t? So let's see, t starts at 0, and so when does a thing get full? So when the thing gets full, then we're done. And let's see, it goes 1/6 feet an hour, and after it's raised 5 feet, then it's going to be completely full, and time will be up, and then it overflows, and whoever cares about that. So if it goes 1/6 feet per hour, that means in 6 hours, it's gone up 1 foot. So it's going to take 6 hours for 1 foot, we have 5 feet, so it's going to be 30 hours. So in 30 hours, it's going to be overflowing. So our domain then for time goes from 0 to 30 as far as hours, because again, 30 times 1/6 feet per hour is 5 feet, and then it's overflowing, and we're end of our problem. Okay, and the range, what can the width be? The range, of course, just goes from, okay, it starts off at 0 width, and the widest it can be is the whole thing wide, which is 10 feet, 5 feet here, 5 feet there, so 0 to 10. Okay, so that's the first part of 9.8, and then I think they ask you next for what the inverse function is. We found the width as a function of time. Now let's find the time as a function of width. So we take this formula again. Let's write it down. So the width is equal to 2 times the square root of 25 minus t over 6 minus 5 squared. Now we want to solve for t, which isn't as bad as it looks. You square both sides. W squared is equal to 4. Then this squared just gets rid of the square root, so 25 minus t over 6 minus 5 squared. Multiply the 4 through. W squared is equal to 100 minus 4 times t over 6 minus 5 squared. Let's put the minus 4 over here and the w squared over there. So that would be 4 times t over 6 minus 5 squared equals 100 minus w squared. Okay, so put the 4 back over here now. So a lot of algebraic steps here, and actually I'm going to start this on another sheet of paper. Okay, so put the 4 over here, and we finally have t over 6 minus 5 squared equals 100 divided by 4 is 25 minus w squared divided by 4, which we can write like this, w over 2 squared, because w squared over 4. And that's the way I think the answer in the book has it, so I'm just going to write it like that. So this is w squared over 4. Now we take the square root of both sides. We get t over 6 minus 5 equals plus or minus the square root of 25 minus w over 2 squared. Okay, so now put the 5 over there. T over 6 equals 5 plus or minus the square root of 25 minus w over 2 squared. And multiply everything by 6. And we know that we're going to want to choose, well, we have to choose either plus or minus, whichever makes sense. And we know that we have to get a time of 0. And so we can't get a time of 0 if we have a plus, because it'll be 5 plus something, and the square root is always positive. So in this case, we have to choose a minus, because that's what makes sense for our problem. So a lot of times when you get this, you have to be really careful when you take the square root, and you have the plus or minus. It's not always a plus, that's what you want. Sometimes it's a minus, and you choose what makes sense for the problem. In this case, the minus makes sense. We multiply both sides by 6. We have t is equal to 30 minus 6 times the square root of 25 minus w over 2 squared. And that is the answer. So if we can measure the width at any time, we can figure out how much time has elapsed. And again, when the width is 0, this is good to check your answer. When the width is 0, this is 0, then we have the square root of 25, which is 5, times 6, which is 30. 30 minus 30 is 0, and we know we got it right, because at time 0, the width is 0. And when the width is 10, then we have 10 over 2, which is 5. 5 squared is 25. 25 minus 25 is 0. The time is 30, and we know that's how long it took. It took 30 hours to fill it, so we know that too. So it makes sense. And the domain of this one is the range of the other one, which is 0 to 10. So again, the width goes from 0 to 10. So, all right. That was 9.8. And really quickly, I'm going to go over 9.9 because it seems confusing, but it's really not that bad. And for 9.9, it's all about the understanding what that phi thing means, and that's how you say it. It's the Greek letter phi. Some people say phi, but phi sounds a bit better. So they have this phi thing here. Then phi says it's the amount of nanograms remaining at t nanoseconds. So phi itself is the amount of nanograms. So it's just a small nano is 10 to the minus 9th. So it's the amount of nanograms, call it ng, at a time t. So it's like phi as a function of time. Okay, that's what it is. So the inverse function phi negative 1, it just finds, if we take phi negative 1 of phi of the time, it just gives us the time back. They cancel each other out. You just get whatever's in the parentheses back. So that's all they're saying here. So when they say, like, they give examples like phi of 0 is equal to 6. So at time 0 there's 6 nanograms, and then at time 1 there's 5, and time 2 it keeps going down until finally at phi of 10 seconds, then there's nanoseconds. Sorry, they're doing nanoseconds, so it doesn't really matter. Phi of 10 then there's 0 left. It's all gone. So if we take the inverse of phi of 10, that's just equal to 10. Inverse function cancels out the function, and we're left with what's in the parentheses. So it's really easy. So, and then the idea is that phi itself tells you how many nanograms. So phi negative 1, it tells you, like, phi negative 1 of tells you how many, what the time is when there's so many nanograms left. So like it says phi negative 1 of 0.5. Okay, so phi negative 1 of 0.5 means at what time is there 0.5 nanograms left? Okay, so that's all they're saying. At what time is there 0.5 nanograms left? That's what phi negative 1 says. It's just kind of the opposite. So that's all. So if you have phi negative 1 of phi, you just put this in the parentheses. Phi negative 1 of phi of 10 is just 10. So, and then the domain and range of phi negative 1 is the opposite of the domain and range of phi. So phi, the domain is what you put in their parentheses, so it goes from 0 to 10. So if we're looking at phi, the domain is 0 to 10, because that's what's in the parentheses. And the range is what you get out, and this goes from 6, starts at 6, goes to 0. You always put the first small one first, so 0 to 6. So that's, and then for phi negative 1, it's just the opposite. If this is the domain, that's the range. If this is the range, that's the domain. It's always the opposite of that. So that's all. Hopefully that helps with 9.9. It's a little bit confusing, but once you kind of understand what they're talking about, this function here, inverse functions, get rid of the regular functions, and you just get what's left in the parentheses. So, okay, hopefully that helps. I think you should be able to complete all the rest of these problems. If you're having trouble, please let me know. I can try to help out, but hopefully it goes well, and try to get them in by tomorrow at midnight. All right, I'll sign off for now.